Hi all. Okay. Only one member have joined. Okay. Please reply. Is it visible? Sagar, fine. Sagar, I'll okay, blur. Okay, fine. Okay, is it clear now? Okay, good evening, Sandeep. Okay, fine. Okay, fine. Only 8 members. 9 members. Good evening, Vittal. Okay, fine. 10 members are joined. Okay, good evening. 12 members. Raghu, fine. Sagar Jadhav. 7 members. 6. Why it is reducing? I think network is clear, right? Audio and video is clear to you people. 7, 8 members are there. Okay, can I start now? Okay, I'll start the discussion on basics of laced columns. Generally the lacing is there. Okay, a design of laced and battened columns. Okay, today in this class we'll be concentrating or we'll be discussing on the lacing system. Okay? Generally what happens when the buckling is quite high. Okay, even your members like I section along with the plate will not able to resist those buckling. Okay, in that case you need to increase the section size. Okay, so many times what happens, you cannot able to increase the size of the section. Okay, I section is restricted 450 mm. Okay, maximum of you can have 450 mm, right? It is there in steel table, the available in the market. Okay, and the many sections are available, those may be built up one, right? Okay, the road sections which are available in the market is 450 mm thick. Here, to increase the radius of gyration, okay, to avoid the buckling. Okay, so I'll be taking a different system, that is a laced system. Okay, here you can see in the figure. Okay, here in this figure you can see the lacing system. First one is a double lacing system, second one is single lacing system. Okay, you can see in the figure, right? Double lacing and single lacing system means it is crisscross. Okay, only one member is used in single lacing, whereas here it is a double lacing system. Okay, and horizontal members are connected, right? Okay, it is batten. Okay, whatever the horizontal strips are there, it is batten, whereas the diagonal strips we call it as a lacing system. Okay, so here you can see the actual lacing, double lacing system in this figure. Okay, before okay, here you need to design. So the section size may be quite high. Okay, section size may be quite high because there it may be around 600 700 mm. In that case, Okay, you need to increase or you need to have the columns in such a way that it can carry the quite heavy load as compared to I sections. Okay, and what the larger dimensions also, in that case we'll go for the, okay. So here we'll be discussing on the before adopted, that is rules for design of ledger for design. Okay, is it clear now? Okay, fine. I think audio and video is clear now. Can I proceed? Yes, fine. Okay, so here what I will do, I'll be discussing on guidelines. I'll not take much time. Only I am here to discuss on the theory part of lacing system. Okay, theory part of lacing system. Okay, so here the first, okay, this is the all single and double lacing system. Okay, whatever, if these are the double lacing system. Okay, and this is a single lacing system. Okay, so here before design a lacing system, we must know the guidelines. Okay, we got 13 guidelines from IS 800. Okay, to design the lacing system. First one, we'll read one by one. As far as possible, the lacing system shall be uniform. Okay, as of now, okay, the spacing of these members shall be uniform. Okay, suppose if it is taking, if spacing or angle, if it is 45-degree throat, okay, from bottom to top, it should be same. Okay, first parameter is it's a spacing should be, or the system should be uniform. Okay, and second one, in a single laced system, the direction of lattice on opposite faces should be shadow of the other. It should not be mutually opposite. Okay, so here what happens, okay, if you are using a single lacing system, okay, so the same image is reflected, that like it should be a mirror image, it should not be opposite one. Okay, mirror image means the same. Okay, parallel bar should be there on other side also. Okay, like in this figure, in cross section you can see. Okay, in cross section you can see. Okay, here what happens, okay, on either side, AABB is a faces, AA is face, whatever the member in BB, that should be same reflected in AA. There should not be any difference. Okay, suppose if it is at 45-degree, that is also should be 45-degree. Okay, suppose if it is in one direction, it's a another direction should be same. Okay, and the direction of lacing member in other side should be same. Okay, here you can see in the figure. Okay, I think it is not visible. Okay, see here, it is double lacing system is there. Okay, no need to worry. Okay, whereas especially in single lacing system, what he says, okay, there should be a correct mirror image should be there on other side. Okay, now the third point is, in a bolted or riveted construction, the minimum width of lacing bar shall be 3 times the nominal dia of bolt or rivet. Okay, especially in riveted and bolted connection. Okay, riveted we will not use because it is not there for academics. Okay, and only I'll be using the bolted connection. Okay, suppose if we are using 20 mm bolt. Okay, what he said, the width of the lacing bar should be minimum 3 times the dia of bolt. Okay, minimum 3 times the nominal diameter of bolt. The third point is there, right? Okay, so for example, if we are using 20 mm bolt, okay, it's a total width is it's a total width of the lacing bar should be 3 times the 20, that means 60 mm. 60 mm should be the minimum width of bar. Okay, third point we are discussing, right? Is it clear? All the 3 points is all the 3 points are clear. All the 3 points are clear. Yes, fine, fine. I'll proceed. Okay. So next, what happens in a fourth point? What he said: the thickness of flat lacing bar shall not be less than 1/40th of its effective length. Okay, 1/40th of its effective length for single lacing, and 1/60th of effective length for double lacing system. Especially here in single lacing system, the thickness of whatever you are seeing. Okay, in a single lacing system, its a thickness should be 1/40th times 1/40th times the length of this bar. For example, if it is 100 mm, okay, 100 mm divided by 40, it is 2.5 mm. Thickness of this member should be, if it is 100 mm, thickness of member should be minimum 25 mm, sorry, 2.5 mm. 100 divided by 40, keep it in mind. For example, if it is in double lacing system, okay, it can be up to 1 by 16th. 100 divided by 16, how much it will be? Okay, that will be the thickness of this member. Okay, this is fourth point, right? Okay, and next, fifth point: lacing bars shall be inclined to 40 to 70 degree. Whatever the lacing bar you are taking, okay, it's a angle. Okay, angle with respect to horizontal. Okay, horizontal, okay, should not be less than 40 mm and should not be more than 70 mm. Okay, it's an angle. Okay, angle should be in between 40 degree to 70 degree, then only it will be effective for members. Then only it will be effective for members. Okay, to the axis of built up members. Obviously it is with respect to horizontal, it's a angle should be 40 degree to 70 degree. This will be the fifth point. Is it clear? Fourth and fifth point. Fourth and fifth point, is it clear? Yes, fine, fine. Okay, no, sixth point. Okay, what is he saying? The distance between the two members should be kept kept so as to kept apart. That actually that is the distance between the two main members should be kept apart so as to get RYY greater than RXX. Earlier, everywhere I think you have solved problem, that is RYY always you got less than RZZ or RXX value. Okay, so you need to keep the members, two members. Okay, two channel sections are there in this figure. You need to keep these sections apart in such a way that you must get RYY value greater than RXX. Okay, RYY value greater than RXX. Okay, so when you keep it apart, obviously the inertia will vary, right? Inertia will vary. Okay, in that case, what happens? RXX, IXX becomes less and IYY becomes more. Okay, when you keep these two members apart, okay, the IXX and IYY of the total built up section will change. Okay, instead of IXX, IYY becomes more. Okay, if IYY becomes more, obviously RYY will becomes more. Okay, so this will be your sixth point. Okay, RYY should be greater than RXX or RZZ. Keep it in mind. Okay, is it clear? This point is clear. Sixth point, is it clear? Yes, fine. Vinayak, next. Anybody, one or two replies? Yes, fine, sir. Yes, yes, thank you. Okay, only I'll check at every step because I must confirm whether you are getting or not. Okay, thank you. Okay, so here next in seventh seventh point is there. Okay, that is the maximum facing of lacing bar shall be such that the maximum slenderness ratio of main members between consecutive lacing system is not greater than 50 or 0.5 times the most unfavorable slender greater than 50. Okay, slenderness ratio should be maintained. Okay, it should be properly maintained. It should not be greater than 50. Okay, you need to maintain the slenderness ratio while fixing or placing the main members. Okay, so you will get this point when you are designing the lacing columns. Okay, seventh point. The next eighth point. Okay, seventh I think will not be clear, right? Okay, so the only the thing is that in seventh point only he said slenderness ratio should be as kept as minimum. Okay, that should be less than 50 mm. Okay, sorry, slenderness ratio is slenderness ratio should be less than 50. Okay, earlier KL by R minimum where you people have calculated, right? Okay, so slenderness ratio should be kept less than 50. Okay, it is in your hand. Okay, when you place it apart, everything will vary. That means RYY, RXX. When you increase the radius of gyration, obviously, the slenderness ratio will get reduced. Okay, seventh point. And next eighth point is the lacing shall be designed to resist transverse shear VT. Okay, sorry, transverse shear VT, that is VT is equal to 2.5% of axial force on the column. For example, 1000 kilonewton is there. So mainly what happens? Mm, the force which is applied will be transferred to lacing system itself. Okay, and due to the applied vertical force, 2.5% of the vertical force is transferred to lacing system. Okay, in the form of shear. Okay, so VT is equal to, VT is nothing but shear force, that is 2.5% of the axial force on the column. For example, if 1000 kilonewton is the load on the column, 1000 into 2.5 divided by 100, that is around 25 kilonewton is the force on lacing bars. Okay, if there are two transverse parallel systems, they each lacing has to resist VT by 2. That means only one system will carry VT. If there are two lacing systems, okay, on front and back will be you can see in the figure. Okay, here at cross section AA and BB, we are getting two lacing systems, right? Okay, so whatever the force is there, 1000 kilonewton is applied and 25 kilonewton is the force on lacing system. Okay, and there are two lacing systems, obviously 12.5 kilonewton on each lacing system. Okay, so that will be the force which is applied on the lacing system. Is it clear? Eighth point is clear. Seventh and eighth point, please reply. Is it clear, please? Okay, Hina, Amaresh, Ashwini, Mega, fine, fine. Okay, so the ninth point. So the ninth point is. So the ninth point is, if the column is subjected to bending. Okay, if the column is subjected to bending, listen here. If the column is subjected to bending, the VT will change. Okay, VT is equal to bending shear stress plus 2.5% of column load. Okay, VT will increase. If it is only subjected to axial load, VT is equal to 2.5% of the total. Okay, if it is also subjected to bending, like your uniaxial and biaxial columns in RC sections. Okay, if the column is subjected to bending, in that case, generally in compression members will not for your academics, we don't have any bending effects on the column. Okay, only we are, as it is compression member means only one force is taken into consideration. Okay, so it will not come into picture, bending will not come, but still you must know this thing, that is VT. If it is in under bending, VT is equal to bending shear stress plus 2.5% of column load need to be added. Okay, and 10th point, the effective length of single lacing system is equal to the length between inner end fasteners. Effective length of single lacing. Okay, so you must design. Okay, not only will design column, We'll design lacing bars also. Okay, it's the breadth, thickness, and length. How many number of bolts required to fix the lacing bars? Okay, here you can see. Here in the figure you can see. Okay, you take single lacing system. Okay, so single lacing system is there. It has some width, it has some length, thickness, as well as at the end we have provided a diagonal bar. Okay, diagonal bar is lacing bar. Okay, keep it in mind. And horizontal is batten. Okay, we are only talking about the horizontal member, sorry, diagonal member. Okay, so diagonal member has two bolts at the end. That means you need to design this member, lacing member, as well as the number of bolts to connect lacing member to the main members. Okay, so that I need to find out. Okay, the next point, the 10th point is about that only. Effective length of single lacing system is equal to the length between inner and fasteners. Okay, it acts as either it may be a tension or compression member. Let it be. Okay, we'll discuss while solving, right? Okay, so this member will be designed in such a way that, okay, always when you design member you must know the effective length. Okay, in 10th point, the effective length parameter is discussed. That is, effective length of single lacing system is equal to the length between inner end of fasteners. That means one bolt to, okay, here we, if we have bolt to bolt, inner bolt to inner bolt will be the effective length of this lacing bar. Okay, so this will be the 10th point. Okay, is it clear? Please reply. Is it clear? Is it clear? Please reply so that I can continue. Eighth point, what happened? Eighth point is witty, that is force. Shadab, it is force applied on the lacing system. Okay, only in problem, only force applied on the column is given to you. You need to find out force, what will be the force on lacing bar. Okay, it is equal to 2.5% of total load applied, right? Ninth column is, if column is subjected to bending as well as shear, you need to add bending shear stress to increase VT. That is, VT is equal to bending shear plus 2.5% of the column load. And 10th point is effective length. Okay, it is inner to inner, distance between inner to inner bolt is the effective length of lacing system. Okay, is it clear? Okay, next I will proceed. Okay, so for welded joints and double laced effectively connected at intersection, okay, that means except that this one, effective length will be equal to, except that welding portion, whatever remaining the length of member is there, that will be treated as effective length of lacing system. Effective length may be taken as 0.7 times the actual length, especially in double lacing system, or okay, it acts as a fixed support. It acts as a fixed support, right? In double lacing system as well as in welded connection, the effective length of the welded connection is 0.7 times the total length of the member. Okay, here he has given in the 10th point. Okay, is it clear now? Is it clear? 10th point is clear? Okay, I'll proceed. Okay, so 11th point is what he said, the slenderness ratio KL by R minimum. Even though not only for members, you need to check slenderness ratio for lacing bar also. Okay, so that is KL by R for lacing bars. Okay, it should not be, it should not exceed 145. Okay, you should maintain KL by R for lacing bar. Here we'll get, you'll be getting two members. One is main members, that is column section. Okay, along with whatever the main member we have taken, you need to concentrate on the slenderness of that also. And we are connecting two main members with lacing bars. Either it may be a two member, four member, whatever it may be. Okay, it will be connecting with the lacing bars, right? So in that case, what happens? It's a slenderness ratio to be maintained. Even though lacing bar slenderness ratio to be maintained, that it should not exceed 145. Okay, it should not exceed 145. Is it clear? Okay. Next, I'll proceed to 12th point. Laced compression members shall be provided with batten plates. Okay, even laced compression members shall be provided with battened plates. Okay, that means what? What does it mean? Okay, here you can see in the figure. Here I'll show you in the figure, right? Okay, here in this okay, single and double says horizontal. Okay, the vertical members are main members. Whatever exact vertical members are there, those are main members. Okay, and perfect horizontal members, those are battens. Okay, it is of again same material, the same plates will be used, ms plates will be used, and the diagonal members are lacing members. Okay, diagonal members are lacing members. Okay, so you can provide the diagonal members along with the horizontal members. That the 11th point is saying, sorry, the 12th point is there that laced compression member shall be provided with battened plates. It can be provided with battened plates. Okay, the composite both can be provided simultaneously, lacing as well as battens. Okay, today we'll be only discussing on lacing. Okay, another one part is that is on batten, right? Even though you can provide both at a time in a compression member. Okay, is it clear? Okay, is it clear now? Is it clear now? Two members are joined. Is it clear now? Four members. Okay, okay, I'll continue. Okay, we're discussing last point, 30th point. Okay, so here it is 13th point is effective slenderness ratio of laced member, lacing member, that is whatever the diagonal members are there. Okay, it should be increased by 1.05 times. It is 5%. It is increased. It is to be increased because slenderness ratio in order to account for shear and deformation effect. Okay, so it will be under shear and deformation effects. That's why the slenderness ratio will be increased by 5%, that is 1.05 times. Okay, always actual slenderness ratio of lacing bar should be multiplied with 1.05 times the actual slenderness ratio. It is increased by 1.05 times. Okay, 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 is it clear now? Buffering, okay, it is complete only. Okay, everything is completed. Okay, 13th points we have discussed. I'll be sharing these notes. Okay, you read out once again. Just read out these 13 points, you'll come to know everything is clear. Only thing is that okay, you must know what is lacing column, what is lacing bar, what is main member, what is batten. Okay, here in this figure, okay, I'll discuss once again in this figure. Here in this figure, whatever the vertical, exact vertical members are there, those are main members. Either it may be channel or angle, whatever it may be. And exact horizontal members are battens, and diagonal members are lacing bars. Okay, diagonal members are lacing bars. Okay, so these are the three members. Okay, whatever the lacing and batten system design is there. Okay, only these will come into picture. Okay, this thing is there. Okay, especially what happens. Okay, here we can see in this figure, we can see only two main members, the channel members are used. Okay, sometimes what happens, okay, it is also used. Okay, you can also use four members. Here in this figure also we have they used two main members. Okay, in this figure also they people have used two main members, right, along with the lacing. Okay, and sometimes the four members at corner will be used. Okay, if you stay online for 30 seconds, I'll show you. Okay, okay, here in this figure, okay, you can see these are the cross section of the lacing or battened columns. It may be lacing or batten. Okay, this is lacing column. First one is lacing column, and second one is battened column. Okay, here you can see in the figure, right? Okay, is it clear? The audio and video is clear. The first column is lacing column, second one is battened column. Okay, these cross section of these columns may be like this. Okay, for first in first image, the cross sections. Okay, whatever the cross sections you are watching here. Okay, that is first one is the channel sections along with either lacing or batten. Okay, it is face to face channel sections in first one, and second one is a back to back channel section. Okay, and third one is eye sections, which is used for batten and lacing column, and fourth one is angle sections used for batten and lacing column. Okay, battened as well as lacing column. Okay, these many types will get in lacing as well as battened columns. Okay, here you can see only four angles have used. Four angles have used at every corner, and we have four lacing systems. Okay, two in ZZ direction and two in YY direction. Okay, four lacing systems are there. Whereas here two eye sections have used. Two eye sections we have used, and two lacing systems we have. Okay, which is parallel to y axis. Okay, two lacing systems parallel to y axis. Okay, so here it is two parallel to y axis and two parallel to z axis. Okay, here in this angles, the lacing system with angles, two lacing systems are parallel to y axis and two are parallel to z axis. Whatever the dotted line outside is there, right? Okay, this is lacing system or batten system. Lacing or it may be batten. Okay, what type of connection may be there? Okay, so whereas here four systems are there. Okay, that is dotted lines on all the four sides. Okay, so this is two dotted lines are parallel to y axis, two are to parallel to z axis. Whereas here only two lacing or batten systems are there. Eye sections are the main members in this figure, and two lines, two dotted lines parallel to y axis. Okay, those are system. Okay, these are two lacing systems, two lacing or two batten system. Okay, here the channel section is used. Okay, there are two parallel to y axis are there. Okay, there are two dotted lines parallel to y axis, small dotted lines, right? Okay, those are two lines parallel to y axis on the surface of channel. Okay, so those are two lacing system or batten system. Whereas here also, when the channels are placed face to face, okay, again two dotted lines are parallel to y axis. Okay, so on either side, okay, the small dotted lines. Okay, So these are the two lacing system. Okay, these are all first three figures we have two lacing systems. At the last we have four lacing system. Is it clear? Is the concept is clear? Please reply. Is it clear what exactly lacing and batten connections are there? Fine. Okay, I'll ask you one question. Okay, on concrete technology. I'll ask you one question on concrete technology. So I think you might have done a mixed design of concrete, right? Mixed design of concrete. There, they are taken zone of sand. Different zone of sand need to be considered while finding the ratio of coarse aggregate to fine aggregate. Okay, it depends on the zone of sand. Okay, so in that case, how will find out zone of sand, or on what basis you'll find out the zone of sand? Anybody know on what basis you'll know the zone of sand? Anybody know? Please reply. If anybody knows, please reply. On ratio of concrete, no, on other, on their sizes. Okay, how will find out size? Okay, many people will assume that one. Okay, I said, sir, on size, you are right, it is on size, correct, but how can you say directly? Okay, for example, can you able to say, okay, you take uh, one hand of fine aggregate, that is sand. Okay, can you able to say which zone it falls? Which code you'll refer at least? Which code you'll refer at least? On the base of mixed design? No, you are going to find out the mixed design itself. We are designing the mix. Okay, mixed design is depends on the zone of sand, not zone of sand is depends on mixed design. Sieve size, you are correct. Sieve size, at what sieve size hina is correct. Okay, it is on sieve size. Okay, but at what sieve size you will find out. Okay, can you able to say if it is 4 point, if the fine aggregate passing 4.75 mm, it acts as it treated as sand or fine aggregate. Okay, can you able to say it is okay? There are four zones in the same sand. Okay, we whatever the material which is less than 4.75, it is treated as sand itself, right? Okay, so why they have made again four zones in that? On what basis they have made? Fineness modulus 100% correct, Ashwini. Okay, zone 4, what is that zone 4? How will find out? Which code and which table you will refer? Already you people have completed mixed design, right? In fourth semester, IS 10262 only it is there for mixed design, not to find out zone. Keep it in mind. Only people have used only one code. It is wrong. IS 10262 is used for design mix. Reply any other answers. Which code you refer to find out zone of sand? I'm not getting any replies. Okay, you do one thing. Yesterday, I made a video and shared in the channel. Okay, regarding how to find out the zone of sand for mixed design. IS 2386 is wrong. It is IS 383. You do one thing. Yesterday, I made a video of 7 minutes. Okay, I think my channel have since I made this channel 3 years back. Okay, actually we are using now. Okay, so it has many videos which is related to civil engineering. Okay, you go one by one. Okay, watch in your free time. I think you are free now itself. Okay, it's a time of lockdown. Okay, you watch one by one. Okay, you watch one by one videos. IS 383, right? Shadab is correct, but you are too late. Okay. So not only that one, many videos are there how to design even your pavement design, okay, as well as bridge construction. There might be no explanation for many videos, okay. Even construction manage related to construction management and how environmental, okay, many videos more than 250 videos are there. Okay, you might in your free time, if you are interested, you can go and watch, right? Okay, only if you have a free net, don't ask me for net pack and all those things. Okay, in your free time, okay, you better watch how to find out zone of sand. Okay, many technical videos are there. Go through that and find okay, find good for you people. Okay. Okay, thank you. Okay, this much will be the today's discussion on lacing and battened connection. Lacing and Batten connection. These are all comes under built up columns. Okay, yesterday also, okay, we were discussing on built up columns itself. Okay, built up means the I sections with plates, that is also a built up column, and the members along with the angles or plates we are using, that is lacing and Batten connection. These are all comes under built up. Okay, which is not rolled sections, built up we have made and later we have used, right? Okay, we don't have any data related to lacing, batten, and built up sections in steel table. Okay, last at the end, we have I section with the plates. Some pages are there in a steel table. Okay, so apart from that, we don't have any much what the parameters which is related to lacing and batten in steel table. Okay, you must follow these 13 guidelines to design. Okay, thank you.